Hello, kind people. How are we doing today? Good, good, good. All right. So, I don't really think I have any announcements. We are just moving forward. All right. So last time, before we had the test, we were working in 7.1, estimating the population mean when sigma is null. And the main way we estimate the population mean is by creating something called a confidence interval or CI. Yes, yes, yes. Not confidential informant, a confidence interval. No, no. And the idea behind the confidence interval is that if I do some kind of survey, I do some kind of process, and I get a mean, as in this example right here, I got a mean of 67.3. Well, the fact is, we know that this is a good estimate for the mean, but it's most likely correct. Yes? Say 400 students are taking statistics. If I just ask you 25 people, what was your average score on test number 3? That average will most likely not be the actual average for all 400 students. Yeah, it'll be close, but not the exact value. And so, yeah.
Is the exam still this Friday?
For this unit, I will be finished by that day, but I don't think so. Yeah, we should finish by tomorrow and the day after. But okay, I'll double check. Most likely I'll push back to Monday. But that's a good question. Because we just had, yeah, this one takes like about a week to get through. And so that's why it's right after. All right, and so we had our confidence interval right here. And so what happens right here from this score right here, we add what's called an error, or we subtract the same amount an error right here, and that error gives me an interval. And then I can say, for example, I am 95% confident that the true mean lies between these two values. Right? This right here is our best guess. Excuse me, it's called a point estimate. And these two numbers right here is the lower your lower limit for your confidence interval and your upper limit for your confidence interval. And so we're saying, hey, most likely or 95% chance that the true mean lies between these two values. And so what the only thing we're left to do right here is to simply calculate the error. Calculate how did they get the number to add? In this case, they added 10, correct? But that is an arbitrary value. But how do you get the number to add and then to subtract to get to that value? All right? Questions there? All right. So let's go over some terms right here. Your confidence interval right here is made of taking the mean and then adding an error to that mean. That gives us the upper level for our confidence interval. And then when we subtract that error, that gives us the lower boundary value for our confidence interval. All right? And so really and truly, we've got to find that error. Well, that error is made up of multiplying two numbers together. The first number is called your Z critical or your Z star, based upon which textbook you're using. And then you multiply this right here by what's called the standard error. And I'll try to point that out to you on the last test you just took right here, 6.4, 6.5. You couldn't just use the standard deviation. You have to do the standard deviation divided by the square root of n. Yes? That right here, that actually has a name. It is called the standard error. In other words, the standard deviation is the error. When you divide it by the square root of n, you standardize it. Kind of, sort of. And so that's the two numbers that you need. Questions there? So I have to just remind you about this part right here, and then I gotta show you how to find Z star. It won't be too bad finding Z star. And so let's go through those processes, shall we? All right, so your standard error right here, they just want to remind you that the standard error comes from the central limit theorem. And if you remember, the central limit theorem says that if the underlying population, we don't know anything about the underlying population, if n is greater than 30, then we can assume the distribution of the means is going to be normal. Yeah? Yes? But if we know that the underlying population is normal, then n just needs to be larger than 1, correct? Any size will do for us to apply our central limit theorem. Questions there? So again, instead of using the standard deviation, we use the standard error instead, which is take the standard deviation and then divide by the square root of the sample size. Questions there? The key thing here is that as n gets larger, this number will get smaller. My error will get smaller. My standard error will get smaller. And that should make sense to you. The more data I have, remember we had like 400 students taking statistics, right? If I interviewed 25 of them, that's going to be a small population, right? My standard error might be yay big. But if I interviewed, say, 385 of them, right, then my error will get much smaller, yes? Because I'm only missing 15 people to get the actual answer. Yes, and so the more people you put in, the more data you have, the smaller your error is going to be. Questions there? All right. So that's how you find this first piece right here. It's just take the standard deviation. Remember in this section, sigma is known, yes? Take sigma and divide by n. All right, so in the example that they're working on right here, remember we were talking about the reading class. The average on the reading test was 67.13, and 100 people had taken the exam, right? And it was known for these kind of tests, the standard deviation was 15. Well, to find the standard error, you take 15 and you divide by the square root of 100. Square root of 100 is 10, and so it gives me an error answer of 1.5. Questions there? All right, so that's the standard error part. And that moves us on to our other part right here, the critical value. So I call it Z star. They have right here ZC. Both of them mean the same thing. The critical value is tied to how accurate you want your confidence interval to be. As your confidence interval percentage gets higher, your critical value will get higher. Okay, that's the first point right here. Your critical value, your Z star or your ZC right here, is tied to the how confident you want to be. All right. Other than that, to get the actual confidence and actual Z value, you just need to go to salt. Where did I say you need to go to? Salt. So let's head on over to salt. How are you heading over to salt again? It's on the internet. Do I have salt already open? Normally I do. I want to leave this window open. I gotta come back here in a second. So let's go salt. SALT. All right, salt statistical analysis and learning tool. So first things first, you always select a normal distribution. You always set a mean of 0 and a standard deviation of 1. Why am I setting the mean to 0 and the standard deviation to 1? Because it's a standard normal distribution, yes? In fact, they're asking us for a Z critical, right? For a Z score, yes? The next thing is you always select the between system right here, between the two values right here. Always select the between system right here. And then what you do is you go in and put in your probability, the probability of how confident you want to be. You want to be 95% confident? You just type in right here, 95, so 0.95, like so. And so you can see right here, excuse me, it shaded the 95 percent of the curve under the curve is shaded. And then this score right here, this is going to be your Z critical, 1.96. Questions there? The Z critical is just the Z score they give you when putting your percentage of confidence. If I would make this higher, for example, let's make it a 99% confidence interval. Notice that the Z score got larger. Yes, it's going to be 99.9% confidence right here. Again, notice that the Z score gets higher. The more confident you want to be, the higher your Z star, the Z critical is going to be. Questions there? Notice right here, we're ignoring the negative value. The Z score right here, we just take it as the positive value. We put a minus sign back in when we're subtracting, right? Because remember, we have to add and then subtract the error. That's when the minus sign will show up. So we just take the positive value right here. Questions there and find the Z critical using salt. Questions there? All right, so I'll ask you to find one in a little bit. We'll see. And so again, that's what they mean right here by thing right here, doing this whole normal invert thing right here. This is what they're trying to do right here. See the middle 95% is shaded right here, and you get the same two z-scores. You take the positive one as your z critical. Questions there? All right, cool. All right, and so therefore, your maximal margin of error, or simply your margin of error, is called the value E, and E is found by multiplying these two things together, the critical value by your standard error. That's all it is to finding that value E. Question. Z critical comes from SALT. This comes from a calculation. You take sigma and you divide it by the size square root of the size of the population. Questions there? All right, and so with that right here, quite simply right here, if we take the sample mean and we add the error, that gives us the upper bound of our confidence interval. And if we subtract the error, that gives us our lower bound for our confidence interval. All right, shall we do an example? So again, we go back to our favorite storytelling act. They found that the average for 100 students, the average score on the test was 67.3. Your standard error is 1.5. They're doing a 95% confidence interval. Remember, I showed you this was 1.96, a 95% confidence interval. Yes. And so all you need to do is multiply these two things together. 1.5 times 1.96. That gives us an answer of 2.94. And quite simply is you take the average, you add 2.94. That gives us the upper boundary for our confidence interval. And then you take the 7.3 and subtract the 2.94, and that gives us the lower boundary for our confidence interval. Quite simply, we are now 95% confident that the true mean for students who have taken this new reading process is between 67 and 70% rounding. It's between 67 and 70%. Questions there? Comments, queries, concerns. So another way of saying this right here, if we give another 100 students the same procedure, and when we have them take the test and get the average they will get will be somewhere, most likely 95% chance, the average they'll get will be between 64 and 70 points. Right? If we gave every single student in the district, every single student possible, this new system, and then they took the test, the average score they will get would be between 64 and 70. Questions there? So if the old way of teaching, our students' average was 50%, it'll make sense to switch to this new method. Yes? Right? But if the old way of teaching, the average was 70%, then it would not make sense to switch to this new system. Right? The system is no better than what we are currently doing. Questions there? All right, let me show you one last thing right here. For some reason, SALT does not have a confidence interval. If you go over here to inferential statistics right here, you see how it says one sample T. It does not have a one sample Z on here for some reason. I don't know why it doesn't have a one sample Z on here. And so I have included one for you guys. So if you go to the course webpage and we go to unit 5 estimation, you'll see right here confidence interval calculator. If you click on this right here, it will take you to calculator.net. They have on here not hundreds, they have on here lots of free calculators, and one of the ones they have is for your confidence interval. So in here, there are 4 numbers you need for your confidence interval. The sample size, there were 100 students. The average from the 100 students, that was 67 point, anybody remember what was 67.34? I go back and check. It was 67.3. So 67.30. And then the standard deviation was 15. Standard deviation was 15 points. And my confidence level, I wanted a 95% confidence interval. Yes? So you can enter right here, it'll calculate for you. And so you see right here, it has 67.3 and it has plus or minus your error, the 2.94. And then actually gives you the confidence interval. Questions there? The reason why I like this calculator right here is that it actually shows you all of the steps to follow it right here. You take the average and then you multiply the critical value, 1.96 times the 15 divided by the square root of 100, right? That's the steps that you follow. And so that's how they got the same 2.94 that you add and subtract to the 67.3. Questions there? Well, the reason why I like this one even more is that not only that right here, it kind of reminds you what a confidence interval is. If you, in case you've forgotten right here, and then how to write out your confidence intervals. It gives you some of the basic ones. A 95% confidence interval is 1.96. With a 99% confidence interval, 2.576. With a 99.9% confidence interval, 3.291. So it gives you a lot of information on there. Questions? Ah, cool. Cool. I think that's the end of this one right here. So I'm gonna go back to my next page. All right, so still in 7.1. Again, just going back over the terminology right here. Point estimate, that's a single number. Take all the numbers up, all the scores, and divide them by 25. That's your point estimate. Your confidence interval is the range, a lower limit to an upper limit. Yes? Your confidence level, I want to be 95% confident. That will always be given to you. Your critical value right here is a z-score that comes from the confidence level. As the confidence level grows, your critical value will get larger. Your standard error, we never use the actual standard deviation. We take it and we divide by the square root of n. And then your margin of error, that is you multiply two things together, your critical value by your standard error, and that gives you your margin of error, capital E. Yes? All right, cool. Cool. All right, so I already talked about this already, but what happens to your error as your confidence level decreases? The maximal error will also decrease, right? In other words, as this area gets smaller, as in I am less confident, this number will get smaller. And if that number gets smaller, then your error will get smaller as well. All right? Questions there? All right, go ahead, use salt for me, please. Go ahead and find the Z star, the Z critical, if you want to create a 92% confidence interval. Go ahead and use salt to solve this problem right here for me, please. Find the Z star for a 92% confidence interval. Go ahead, use salt. And you come over your shoulder and watch me go back. So you should pull out salt. Then remember, you have to click on between, correct? And then what you do with the 92%? Just the salt to other side. All right, anybody want to tell me what the answer is? 1.75, is that what we got? 1.75? Then why you don't say something? You don't just let somebody else say the answer? All right, so come over here. Where is it? Oh, there we go. And then we go into salt right here. We select distribution calculators. We click on between. We make sure there's a 0 and a 1 right here. And then we put in, we want to be 92% confident. This right here is your score. 1.75 to two decimal places. Questions there? All right. So again, this is how they did back in the old day. But we got the answer right here, 1.75. I guess it was just so much more work to do it back in the old day. You guys don't know how much joy and happiness you guys got away from. If we want to be more confident, what we must do is increase the critical value, i.e., the margin of error will increase. So the problem is that the higher the confidence level, the wider the confidence interval is going to be, and sometimes that makes the interval useless. Yes? Let's say, for example, we want to figure out the average amount someone wants the say students will pay for a t-shirt. Yes? Let's figure a confidence interval between 50 cents and $300. Does that help us figure out how much students are willing to pay for a t-shirt? No, right? And so there's a trade-off, right? The more confident you want to be, the larger the confidence interval is going to be. And so that kind of spreads out the upper and lower limits. And sometimes that can make the interval not really useful. Right? Questions there? And so that what they're saying is a trade-off right here. As the confidence grows, the margin of error gets larger, and so the interval widens. Sample size on the other hand, does the reverse. The sample size number of people you're talking to, correct? Well, the more people you talk to, the more data you have, yes? And so what happens is the more people you talk to, the smaller your confidence interval is going to become. Okay? The reason why is because you're dividing by n. So as n gets bigger, this whole thing will get smaller because I'm going to divide. Instead of dividing by 10, if I divide by 100, if I divide by 1,000, it's going to become a smaller number, yeah? Right? And so the more data you have, the more information you have, the smaller your error is going to be. Good afternoon. Okay, and that gives us this interesting formula right here. Let me see if I can zoom on for us right here. If we want to hit a target size on terms of our error, we can calculate the population size that we need using this value, right? So let's say I want my error to be 3 points, right? Let's say I'll try and figure out how much students are willing to pay on average for a t-shirt, right? And I only wanted my error to be 3 points. Then what I do right here is you use this formula right here to figure out the size of n. So let's say I want to be a 95% confidence interval. This means this is going to be 1.96. Let's say the standard deviation for students buying t-shirts, that standard deviation is about, say, $10. And I want to be 3 points off. I just plug those three numbers in and then square it. And then that'll give me the population size. This is how many people I need to include in my sample to be within 3 points. Questions there? Questions there? All right. We have an example for you. Yeah, come on, be nice thing. So yeah, by the way, the way they got the formula right here is that they just did the math right. They're solving for square root of n. So they multiply both sides by square root of n and then divide by e. So that's why the e is down there in the bottom right here. And also you have to remember that whenever you're doing n is number of people, so it has to be a whole number, yes? But you always round up when you find n. So even if you've got a score of say 200.2, it's still gonna be 201. You always round up. All right. Example, scientists want to estimate the mean weight of mice after they have been fed a special diet. From previous studies, it is known that the weight is normally distributed with a standard deviation of 3, right? How many mice must be weighed so that a 95% confidence interval will have a margin of error of 0.5 grams? So, in other words, they've given us E, right here, 0.5. Z critical is going to be equals to 1.96 because this is going to be Z for a 95% confidence interval. But we just did this in salt a second ago, yes? A 95% interval means that Z is going to be this amount right here. And we know that the standard deviation, sigma, is equals to 3. So we put those three numbers in, we square it, and that gives us the size for n. Make sense? Make sense? So I hit done. So that's the formula. They find Z critical 1.96 using salt. Sigma is 3, plug it in. And then E is 0.5, plug that in into your handy dandy calculator and give us an answer of 138.2. But we're going to round. So it's going to be 130, 139. And so they will need to have in their sample at least 139 mice. Questions there? Comments, queries, or concerns? All right, cool. Cool. We don't need to do this with the TI-83. See, the TI-83 did a Z interval. I have no idea why salt doesn't do a Z interval. That's why I had to go online and find the other calculator for you guys. But again, notice you just need 4 numbers. You need the mean, the standard deviation, the sample size, and your confidence level. You need 4 numbers to create a interval, to create a confidence interval. Questions there? All right, a full example. A machine that fills cereal boxes is supposed to put 20 ounces of cereal in each box. A random sample of 6 boxes is found to contain a sample mean of 20.25 ounces of cereal. It is known from past experience that the fill weights are normally distributed with a standard deviation of 0.2. Construct a 90% confidence interval for the mean fill weight. So what we're going to do is we need to find X bar and then add and then subtract the error. Yes, that's the basic idea. You need to take the mean and then add the error to get the larger value, subtract the error to find the lower value. Yes? X bar is given to us right here. The sample mean is 20.25, 20.25. And so that is our sample mean. And plus or minus, the error is found by multiplying 2 numbers together. That is going to be Z critical multiplied by the standard error. Questions there? What percent confident do we want to be? Very confident, right? And so that means we got going to salt to find that number, yes? Yes? Or we could go into, where did it go? Oh, we could go into right here, down here, to be 95% confident. 90% confidence is 1.645. Yes? Oh, we can go ahead and we can pull it up. Since it's not like 92, it's a standard value, 1.645. And then we multiply that by the standard deviation, 0.02, divided by the square root of 6. Okay, so plug those numbers in, press enter, and that gives us our confidence interval between 20.12 and 20.38. We are 90% confident that the mean weight that the machine of cereal that the machine is releasing is between 20.12 and 20.38. Questions there? Questions there? Again, you don't have this calculator right here, so the way you do it right here is you come here and you'd put in there are 6 boxes. And then the sample mean was, I forgot already, 20 points. Go back one slide. The mean was 20.25. The standard deviation was 0.2. And we wanted to be 90% confident. Yeah, 90% confident, and then calculate. And you can see it got the same answer right here. 20.2 to 20.38. Questions there? So again, you just need these 4 numbers. Between 20.12 and 20.38, that's the machine is going to give, that's the average amount the machine is going to give is between those 2 values. Questions there? Now, the reason why this is good right here is that on the box, they're going to write 20 ounces of cereal. Yeah, that's what they're going to write on the box. Yes. If you take them to court, try and say, hey, they aren't giving me 20 ounces of cereal. This is what they will tell the judge. Hey, we know for a fact, or we're 90% confident that the amount of cereal is between here and here, which is larger than 20. So we're giving you extra on top. Yes. And that evidence will be enough for them, the judge, to say, yeah, you're not right. You're getting more than enough cereal. Questions there? Does that mean that the machine will never give out, say, 19.8 ounces? No, right? It's the average. There's a standard deviation, there's an error. Sometimes it produces more, sometimes it produces less. But on average, it is going to be above 20 ounces. All right. So sometimes they give the problem this way. A random sample of 8 Samsung's Galaxy smartphones being sold on the internet in 2014 had the following prices. Don't laugh. Don't laugh. Right now, you can get a Samsung for $1,499. You can get one for that price. Right, and so for this problem right here, we need to create a confidence interval for this one right here. So one of the nice things for this question right here is that you can enter all of these numbers into Salt, and then Salt will actually do the work for you. Let me make a recording of the numbers. All right, so let me show you how you do this right here. So you head into Salt, your good buddy Salt, right here. And then you go into a data set right here. And then am I going to upload a CVS so I can just enter the data? Let me upload a CVS of raw data. I should have an old one from back in the day that I can upload. If not, I'm going to have to make me one. Autos, test data. It looks like I'm going to have to make me one. So give me 1 second. So all right, so I am going to go into Excel. Where's my good friend Excel? Right here. And my good friend Excel, going to create a new window. Let me make this a little bit bigger. All right, and so in the first row, you're going to put in, what was this data? This data was the Samsung Galaxy smartphones cost. So COST. And then the first one was 149. 149. Then the next one was 135. Then 249. Then 349. Then 299. 249 and 199. And then 169. And you're going to save this, Command Shift S. You're going to save this. I'll put in my downloads folder as a CVS, comma, separated file, CSV file. Yes. What's the name? Cost. Let's call it C. I gotta leave it saved as book 3 for some reason. Not let me change the name. All right, so I saved it as a CSV file. And so now if I go into Salt, SALT, sign. If I go into Salt right here, I go into Data Set, and I go to Upload a CSV, raw data. Like so, you upload this file right here, books, and then select all, just because there's just only one value, and you can see it has the numbers right here. Yes. Now remember, I needed 4 numbers to create a I need 4 numbers to create a what's what I'm looking for, confidence interval. And what you simply do is you go into your descriptive statistics right here, and it'll give us the numbers that we need. So if I needed the average, the median right here, here is the average for those values that I was looking at. Yes? And so you just take those numbers, put them in, and then that'll give you what we're looking for. So if I go back over here, go back into the thing right here. And again, so it really doesn't make sense to kind of go ahead and do these things by hand because you tend to make mistakes when you do them by hand. And so you just let the system work them for you. Excuse me. Excuse me. Something stuck back there. And so basically what we need right here to construct a 99% confidence interval right here is we need to find the z-score for your 99% confidence interval. We need to find the mean, and we need to find the standard deviation, right? So see right here, they give us the population standard deviation of 85. That number is given to us. And so then that should be all that we need to plug in to find our confidence interval. So we would go to the website that I had opened right here. What was N? How many phones are on there? So if you come right here, you can see N is 8. And so we type 8 right here. What was the average? So if I come back over here, you can see that the average was, where is the average? Oh, there it is. 22.4.75. 22.4.75. The standard deviation is given to us in the problem as 85. And then we wanted to form a what percent? 99% confidence interval. 99. And hit calculate. And there you have it. 147 to $302 right here is your average cost for your Samsung phones. Questions there? Or your confidence interval for your Samsung phone. Questions there? All right, cool. I am looking for a quick time. There we go. All right, so there you have it right here. Between here and here, that's going to be your confidence interval. All right, so that's the end of 7.1. We will get started on 7.2. 7.2 is the same concept, find confidence intervals, but this time sigma is not known. The nice thing right here for these ones right here, all of them can be done in Salt. You don't need the other calculator online. Salt does all of these. I have no idea why. I've actually written ask and put it in there, but no one has written back. So cross your fingers. All right. So basically, in 7.1, when sigma is known, we use something called the normal distribution. Remember, we had our z critical right here. That was from the normal distribution right here, and sigma was known. And so because of that, we could use our z's to do our calculation. Whenever we are in an area when the standard deviation is not known, we have to move to a new distribution called the student t distribution. Now, the name for this distribution is kind of weird. What happened was that a professor had a graduate student. The graduate student was working on this distribution, but he left. And so he didn't actually publish, the student didn't have a chance to publish the information. But when the professor went through what he had, he realized what he had was important. And so he published it under the student's name. And so he calls it the student's T distribution. That's why you should write your name down and stuff, people. You should write your name down and stuff. Yes? The student's T distribution, the key thing right here is that it uses the sample standard deviation to replace sigma. Because sigma is not known, instead, we use the standard deviation of the sample itself for an estimate of sigma. Because of this right here, we use this instead, but this right here is not a normal distribution. It is called the student T's distribution. So what does that mean for us? To run the student T's distribution right here, we need a key number, a number called your degrees of freedom. You guys remember we come across this before? Degrees of freedom? Remember when we asked you to find the sample standard deviation, instead of divided by n, we had divided by n minus 1? Yes? We're actually dividing by the degrees of freedom. We didn't tell you that just yet, but we're actually dividing by the degrees of freedom. Quite simply, the degrees of freedom is 1 less than the sample size. So if I have a sample of 50 people, my degrees of freedom will be 49, right? If I have a sample of 20 people, my degrees of freedom will be 19, okay? So why do we need this right here? Why do we need this distribution? Well, it happens quite a lot in the real world. We come across scenarios where the underlying standard deviation is not known. Let's say, for example, Ford creates a new car model that they've never created before. Yes? And they want to figure out, for example, on average, the stopping distance when they hit the brakes really hard on that car, right? They can't use the previous standard deviation from it because there is none, because this model is a brand new model, yes? And so in that case, they have to switch over to this distribution instead. The key thing about the student T distribution right here is that we say it is fatter in the tails. That's how they say it right here. In other words, there is more error that is allowed for in the outer regions. You know, in a normal distribution, mostly everything happens in the middle, and as you go out, the curve falls sharply. So almost all of the information happens in there, the middle. With the student T distribution, this is less so. It is more spread out. It has, as they say, thicker tails. So it allows for more error. It's saying, look, it's bell-shaped. Yes, they're saying it's bell-shaped. They say it kind of looks like a normal graph, but it just has a little more give on the edges because we're working with something where we have less information. Does that make sense? Does that make sense? And so we have our student T distribution. And so what happens is whenever sigma is unknown and the sample size is large enough, we can use the student T's distribution to construct your confidence interval. Questions there? All right, cool. Again, back in the day, this is without technology. You have you could create these things right here, but your T critical values right here, again, they will come from, excuse me, salt. We won't be using tables to find critical values. I don't know why they call this using technology. This is before technology. Before tech, no, no. Yeah, all right. And so, for example, let us go ahead and find one right here. Find the critical T value to construct a 90% confidence interval when your sample size is 7. All right. By the way, what's the degrees of freedom for this question right here? It's going to be one less, correct? So it's going to be 6. So again, we're heading to our good friend Salt. Where is my good friend Salt? There he is. In Salt right here, you go back to distributions just like we did a while ago, but now we make a change. Instead of using the normal distribution, we use the T distribution right here. I guess students couldn't fit in there. The box is too small. So they just say T distribution right here. And of course, C right here is asking for the degrees of freedom. And so we're going to be putting in here. Going to be putting in here in 6 right here. Just like a while ago, we always select between. Just like a while ago, we always select between. And then we just put in our confidence level. Our confidence level was it 95% or 92? Let me go back and see. It was a 90% confidence level. And so we just put in 90%, 0.90. And then this right here, notice they're the same. You take the positive value, 1.9432. That's going to be our critical value. Questions, sir? That's going to be our critical value. Questions, sir? Almost out of time. And so that's how after, 9 hours and pressing enter, you get the same value right here, 1.934. Again, notice it's basically the same as if it was a normal distribution. The difference is we're entering degrees of freedom, right? That's the only difference right here, only using the student T distribution. Question there. Again, the key thing right here is sigma is unknown in this section right here. All right, I think that's the end of the section. Yeah, I think that's the end of the section right here. So, notice right here to find the error is basically the same formula. The difference is instead of a Z, we have T, and instead of sigma, we have S. Remember, sigma is unknown. Yes? But other than that, it's the same process right here. Okay? And last note before I send you guys on your way, if you go over into inferential statistics, you see right here how it says one sample T. Yes? It, it can, I don't need to go to calculator.net. It'll do it for me right here. I don't know why there is no one sample Z. It's like, it's hidden there and there. You just can't see. But there is no one sample Z. That's why you have good calculator net, but it will do it right here for you. And so you just click on confidence interval. You put in the mean, standard deviation, and sample size and the confidence interval. Remember, you need 4 numbers to create a confidence interval. Yes? And then you hit calculate and it'll do it for you. But we'll do that next time. Questions there? That's basically the end of 7.2. All right. I need. Broadband, Brown, Dixon, Dowdell, Elias, Etienne, Gaudreau, Germany, Gibson, Gear, Holt, Key, Catrelli, Lewis, Lloyd, Mao, yeah, Merriweather, Moore, Perez, Phillips,
Here.
Piper, Ramirez,
Here.
Roll, Roper,
Here.
Watts, Jackson, Williams, Young. All right, and you guys have a nice day.
Okay, so I got my homework done, but you know the other ones that were asking for specific problems to be uploaded? Can those be reopened?
Just send me an email of them, please.
I had even heard about the Cleveland, but I took the second attempt. Was that okay?
Doesn't matter which attempt you take, it takes a
As
higher.
long as I do it.
Yeah.